Okay, so is a anti So this video is about antiderivatives. And what we are going to do in essence is we're going to do the opposite of taking the derivative. So we're going to get back to what we started with. Okay. So we have one slight issue. And the issue that we have is when we have constant terms. And so what I mean by a constant term is my pen. If I were to have something like, say, 2x squared plus 3. If we were to take the derivative of that, we would end up with 4x, right? And this constant term 3 would go away. So then if I'm going to undo what I just did, I would know that instead of subtracting 1 from this exponent, I would need to add 1. And I would have to undo that multiplication of 2. So in essence, if I were to undo this, it would be 4 times a half, because that's undoing the 2 multiplication. And then we're going to add 1 to the exponent here that was 1, and so it would be squared. So I would get back 2x squared. So what did I lose going backwards? I lost my constant c. So what we're going to do whenever we take our antiderivative, we're going to add plus c to account for the fact that we could have a constant. And we're actually going to learn how to solve for it closer to the end. Okay, so let's go ahead and run through some examples. Okay, so in this case, what we're going to do is we're going to write a large F, and that's going to indicate to me that this is the antiderivative. Okay, so what I'm going to do is I am going to notice that I need to add 1 here to my exponent, which is going to turn it to 3. And I know that if I started with 3 as an exponent, I had to multiply that down in front of the x. So the 3 is actually going to go away, and I'm going to end up with x cubed plus c. So remember, we're always using c because we need to account for the fact that I could have a constant. All right, so let's go ahead and try another one. So in this case, I'm noticing that I have a negative exponent, right? So I'm going to rewrite this as negative 9 x to the negative 10. So if I'm thinking about this, I know that I would need to add 1. So if I were to add 1 to that, that would turn that into negative 9, right? So that means I started with a negative 9, and that negative 9 got placed here in front of the x when I took my derivative. Okay, so that means I'm going to end up with x to the negative 9th plus c, which you could also write that as 1 over x to the 9th plus c. Okay. All right, we got one more that we're going to do together. Okay, so in this case, it's giving me the derivative of sine. So you need to think backwards. What gives you a derivative of sine? So you're probably thinking cosine, but if you think about it, okay, cosine is actually, when you take the derivative, it's negative sine, but this is a positive. So that's telling me that I had to start with a negative cosine in order to end up with a derivative of positive sine. Okay, and again, we're always putting the plus c. Sorry that I wrote it so close together. Okay, so I have a few more notes that I want to make about some new things. Okay, so I thought I went to the next page, but I went too far. Okay, so we have the notation d dx, and what that is telling me is it just means you're taking the derivative of your function f with respect to x. So new notation, this guy right here is telling me that I have an indefinite integral, okay? So integral is actually the opposite of taking the derivative. So when you integrate something, you anti-derivatize it, which that's not a word, I just made that up, or underivative the problem. So whenever you see your integral sign, after it is called your integrand, and the integrand also is always followed by dx. That is telling you that they took the derivative with respect to x. Just like when we were doing our implicit differentiation and we had something like dr, which means we took the derivative with respect to the radius, or dh when we took the derivative with respect to height. Dx means we take the derivative with respect to x. So I kind of just said that. So x is our variable that we use for our integration. And this notation here represents all of your antiderivatives, okay? Okay, so let's go ahead and we're going to rewrite the three problems that we just did using our new notation. Okay, so what it would look like for the first one, it would be like my integral symbol, three x squared dx, and we got the answer of x cubed plus c. Okay, all right, so pause the video real quick and you try the next two. Okay, so hopefully you paused. So for the next two, you should have gotten -9 over x to the 10th dx, and that equals 1 over x to the 9th plus c. All right, one more. And there we go. Okay, so let's talk power rule. Okay. So I feel like the way this is written, it's probably more confusing to you than the actual rule. But what it essentially is saying is when you have an exponent, what you're going to do is you're going to add 1 to whatever the exponent is, and then in front of the x or whatever variable you have, you're going to do 1 divided by that new exponent, okay? So for instance, let's just say I have something like, I don't know, 12x squared, okay? So what you're going to do is you are going to add 1 to this, so it's going to turn to 3. And then you're going to, since this is 3, you're going to take and say, okay, I need to put a 1/3 in front of here. Okay, so then I would take care of 12 divided by 3, which would give me 4, x to the 3rd. And we'd still have the plus c. Okay, So you can check to make sure that you did this correctly, because I started with my derivative as 12x squared, and if I take the derivative again, I'm going to get 3 times 4, which is 12, and 3 minus 1, which is 2. Okay, so yay, I did a good job. Okay, so let's learn one more rule, and then we're going to do a couple of examples. Okay, so what this first rule is telling you is that if you just have a random number, you can take it and stick it on the outside of the integral symbol. Just focus on the variable itself, and then you could remultiply it back in. The same thing applies when you have multiple things that you're adding and subtracting. You can split them up individually. Okay, so let's go ahead and do this next example. Okay, so in this case, what we're going to do is we're going to split up each one of these, and we have 1, 2, 3 pieces. So we're going to say the integral of 3x to the 5th dx. So after every single thing, you're going to write dx, plus the integral of 2 dx, plus the integral, oh, it's, yeah, well, technically it's -5. Okay, we'll just write it on the other side. Negative 5x to the -3 over 2 dx. Okay, so now what I'm going to do is I've got some constants, so I am going to take them out. So I'm going to take out the 5, the 2, and the -5. So I'm going to end up with 3 integral x to the 5th dx plus 2 integral dx. Whoa. Come on. It's thinking. Okay. Dx minus 5 integral x to the -3 over 2 dx. Okay, so now I can go ahead and do this problem. So what I'm going to do is I'm going to say that this first term, x to the 5th, I'm going to add 1 to it. So I'm going to end up with a 6. So I'm going to end up with 3 from the outside times 1/6 x to the 6th. Okay, and then we'll take care of it in a second. Let's just finish all the problem. All right, so there is essentially a 1 here, right? So I know what's the derivative that gives you just a 1, and that would be when I just have an x term. Okay, so this is going to be 2 times x. All right, and then this one's going to be a little yucky. Okay, so you're -5. So we're adding 1 here. So if you're adding 1, that's going to turn this into -1/2. Okay, so this is the part that's going to be a little bit messy. You're still going to do, just like we did for the 6, was multiplied by 1/6. This is going to be multiplied by 1 divided by -1/2. And I'm writing it this way just so that we keep the convention the same, so you can get used to the pattern, because I know that that's not how we write things normally. All right, so that's going to be x to the -1. All right, and then we write plus c. Okay, so now just simplify, clean this up. We're going to end up with 1/2 x to the 6th plus 2x. All right, if you do -5 multiplied by 1 divided by -1/2, that's essentially -5 times -2, which is going to give me a +10. And then I know that if I have x to the -1/2, that's going to drop down and be under the radical, and then plus c. And that's it. Okay, let's do another one. All right, so this one looks like to me they probably did the quotient rule since I ended up with a fraction. So we don't have to undo the quotient rule portion. All we need to do is simplify this before we try to integrate, okay? So what I mean by simplify is I'm going to take and I'm going to do 4x to the 19th divided by x squared and then negative 5x to the negative 8th divided by x squared. Okay, so I'm allowed to split that up since I only have one thing in my denominator. If I had two things, I couldn't do this. So we're going to say 4x to the 19th divided by x squared. That's squared. Just trying to make him look nicer, but no dice. Dx. And then minus, all right, I'm gonna put plus, minus negative 5 x to the negative 8 for x squared dx. Okay, so we're going to simplify, meaning I know that 19 minus 2 is 17, and I'm also going to take my constants out when I write this next step. So I'm going to say 4 integral x to the 17th dx minus 5 integral. Okay, so this case, I've got a negative 8 in the numerator, so that means if I bring the negative 2 up to the negative 8, it's going to be a negative 10. Okay, so now we can go ahead and integrate. So we're going to add 1. We're going to add 1. So that's going to give me 18. So I'm going to say 4 times 1 over 18 x to the 18th minus 5 times negative 10 plus 1 is negative 9. So negative 1/9 x to the negative 9 plus c. Okay, so now we clean it up. 4 times 1/18 is going to give me 2/9 x to the 18. And then negative 5 times negative 1/9 is going to give me positive 5/9. And since this is a negative exponent, I want to go ahead and drop him down to the denominator. So we're going to say 5 over 9 x to the 9th plus c. All right, fantastic. Okay, so I want you to try the next one. So definitely you're going to want to distribute the 5m in before you try to integrate. So you're going to distribute that, you're going to split up your stuff, take out your constants, okay? You will end up with 12m to the 5th minus 50m cubed divided by 3 plus c. Okay, so I want you to try that. If you don't get it, let me know. I'll send you my work and we can chat about it. Okay, so just like we were dealing with before, what is this? Oh, it's weird. This is telling you what the integral is for a trig function. I feel like this is more confusing than if you just actually think about, okay, what is the derivative of this and work backwards. So let's just go ahead and run through a couple of examples with our trig. Okay, so in this case, there's two things that I want you to notice here. I want you to notice the fact that this is 3x, which means to me that at some point I had u equals 3x when I did my derivative, and I knew that the derivative of that is going to be 3. Okay. And so then the other thing that I want you to think about is the fact that we have secant squared, and what gives you a derivative of secant squared? Tangent, okay? So I know that my initial problem would be 1/3. And why is it 1/3? Because there's no 3 in the front here. So I know that in order to get rid of the 3 that happened when I took the derivative, I need a 1/3, okay? And then we're gonna have tan of 3x. And that's gonna be plus c, okay? Okay, so let's do another one. Okay, so in this case, we have a cosine. And if you're thinking to yourself, okay, what gives you a derivative of cosine? And the answer is sine, all right? So I know that I probably have sine of x divided by 2, right? Okay, now, so think about this though. If I have an x divided by 2 in my parentheses, that means I probably had to do, again, the chain rule. So if u was x over 2, that's essentially like saying that I have 1/2 x, right? So then what would be the derivative of 1/2 x? It would just be 1/2. Okay, so I don't see anything in the front of this cosine that happened when I took the derivative. So what's the opposite of having 1/2? It's 2. So in the front here, I needed to have a 2 sine x divided by 2. Now you can check these to make sure that you did this correctly. So if I were to take the derivative of this, and of course, don't forget my plus c, I would say that u is 1/2, which would mean I would get for my derivative 1/2. So then what's the derivative of sine? It's cosine, so I would end up with 2 cosine of x over 2 times the 1/2, and the 1/2 would make the 2 go away. So then I would end up with the same thing that I started with. Okay? So we got one more example. Okay, so in this case, we have two things, and so I want to split them up when I think about doing my integration. And you are going to end up having to do the chain rule for both of these, okay? So if you think about that, what gives me a derivative of sine? All right, and we know that sine and cosine are related, but cosine, when you take the derivative, is negative sine. Is this sign here negative? No, which means I needed to start with a negative, so negative. Now, this 4t, I don't see a 4 in front, which means I needed to multiply by 1/4. So we're going to have negative 1/4 cosine of 4t. Okay, so that's the first part. All right, now here I do have a negative sign, so that means this is going to be a positive cosine. And you see how I have a t divided by 4 in my parentheses here? So that's telling me that since there's nothing in the front when I took the derivative, that I had to multiply by the 4 by 1/4. So I end up with a 4 in the front and t over 4, and we're going to say plus c. Okay, so the trig ones definitely, they take a little bit of time to get used to work backwards. And just be really careful of your positives and negatives. All right, let's do one more like this. All right, so this one you definitely want to simplify before you deal with this because there's a lot going on. So just like the earlier example when I had a fraction, I can split this up. So I could say sine theta over cosine squared theta. And that's d theta after. -1. Ooh, that's really sloppy. Okay, so in this case, I want you to think about the fact, what is 1 over a cosine? And the answer is secant. Okay, so I can change this to say secant squared theta. And it's still negative, so I'm just going to take the negative and put them right here. So -1 d theta. Okay, theta. All right, and then this guy, I actually want to split this again. So since I have cosine squared at the bottom, that essentially means I've got 2 cosines, right? So I could think of this as sine over one of the cosines, which hopefully you're like, oh, that's something else. And then 1 over cosine. Okay, so if I've got sine over cosine and 1 over cosine, that means that I had tangent and secant. Okay, so integration of tan theta, secant theta, and d theta. Ran out of room a little bit. Okay, so then the question you need to ask yourself is, what gives you a derivative of tangent something, secant something? And the answer is secant. So we're going to say secant theta minus, all right, so what gives you a derivative of secant squared theta? The answer is tangent. So we're going to say minus tan theta. And plus c. Okay. Okay, so now what we're going to do is we are going to learn how to actually solve for the c. Okay, and these are called initial value problems. And so what's going to happen is they are going to give us a differential equation. That means an equation that they took the derivative of. And they're going to give us an initial condition. Okay, and we're going to use that initial condition to find our c. Okay, so this whole next section is about finding c. Okay. All right. So, all right, so we're going to go ahead and do this. We're going to start by finding the integration for the derivative. Okay, so it's going to be 2 plus 1, which is 3, so 1/3 x cubed. All right, and then there's a 1 here, so we're going to add 1. So we're going to say that this is 2. So it's going to be -2 times 1/2 x squared plus c. Okay, so if I just clean that up a little bit, I'm going to end up with 1/3 x cubed minus x squared plus c. Okay, so now what I'm going to do is I'm going to take my initial condition, which is telling me that when I plug in 1 to my initial function, I will get 1/3 for my answer. Okay, so that's telling me that 1/3 equals, I'm plugging in 1 for each of the x's. Okay. So that's going to give me 1/3 minus 1, which is going to give me negative 2/3. Then we're going to add 2/3 to the other side. So that's going to tell me that my C is going to be 1. Okay, so now we're just going to rewrite it, plugging in the 1 for C instead. So you're going to say and that's it. Okay. Let's do another one. Ooh, yuck. Look at this problem. Okay. So definitely let's think about this. We've got 4x to the 1/2, right? This is 6 divided by the square root of x, so that's essentially telling me I've got 6x to the negative 1/2, right? And then this whole thing is divided by x squared. Okay, so just like we did this earlier in the video, we simplified this, we're going to bring this x squared up to each of these, okay? So I'm going to end up with 1/2 minus 2, so that's going to give me 4x to the negative 3/2 plus 6x. All right, so now we have negative 1/2 minus 2, so that's going to give me negative 5/2. Okay, so this is going to be a little teeny tiny bit messy when we are dealing with this integration here. Okay, so essentially, we're going to be adding 1, right? And that's going to give me negative 1/2. So what I'm going to get is I'm going to get 4 in the front, the fraction of 1 divided by negative 1/2. X to the negative 1/2 plus 6, right? So if I'm adding 1 here, that's going to give me negative 3/2. So x to the, oop, I forgot something. Boop. Okay, so 1 divided by negative 3/2. There we go. X to the negative 3/2 plus C. Okay, so let's clean this up. We're going to end up with negative 8x to the negative 1/2 minus 4x to the negative 3/2 plus C. Okay, so I'm going to get rid of my negative exponents just because I don't like them. So negative 8 over the square root of x minus 4 over, I'm just going to leave this as 3 over 2. I'm not going to turn it to a, not going to turn it from the rational exponent. All right, and then that's plus c. Okay, so now we're going to take our initial condition. So they're telling me I'm plugging in 1 and I'm getting an answer of 4. So go ahead and plug in 1. Come on, I need more room. Okay, so 4, so we're going to say okay, so it's going to equal 4. And if I take care of all that, that's going to give me a C value of 16. Okay, so now I can write my final answer as okay. Fantastic. All right, let's do one more. Excuse me. Okay, so the first thing that I'm going to do for this problem is I'm going to distribute the 4 to both of these terms. So that's going to give me 4 cosine u minus 4 sine u. Okay, so in this case, you got to remember, what is the derivative that gives you a cosine? And the answer is a positive sign. So we're going to end up with you hear Chloe purring? She's purring really loud. Okay, and then the next part is we have a negative 4 sine. And also for this one, I know I'm going to have the chain rule going on with this too. Okay, so that's telling me if I have a negative sign, that means I started with cosine, and it was a positive cosine, right? So plus, all right, so I have this 2 and I have this 4, so it's going to end up with 4 times 1/2 cosine 2u. And that's going to be plus c. Okay, so clean it up. We end up with 4 sine u plus 2 cosine 2u plus c. Okay, so let's go ahead and plug in. So we know that this is going to equal 0 when I plug in pi over 6. So we're going to say 4 times the sine of pi over 6 plus 2 times the cosine of 2 times pi over 6, which is going to end up giving me pi over 3. That's a 6. Why did it go like that? Okay, so 6 plus c. Okay, so thinking to my unit circle, we know that the sine of pi over 6 is 1/2. So this is 1/2. And then the cosine of pi over 3 is also 1/2. So we're getting 4 times 1/2, which is 2, and 2 times 1/2, which is 1, which gives me 0 equals 3 plus c. So that tells me that my c has to be -3 because I'll subtract them over. Okay, so let's write everything out now. Okay, so we're going to end up with bam. Okay, so the last thing that we're going to talk about is using our initial value skills to relate position, velocity, and acceleration. Okay, so remember that we have our position function, and the derivative of that is our velocity function. And then the derivative of the velocity function, or the second derivative of the position function, is acceleration. Okay, so now what we're going to do is we're going to use this information to solve these initial value problems. Okay, so let's start with our first example. Okay, so in this case, we are given velocity and it wants us to find the position function. So what we're going to do is we are going to ask ourselves, what gives us a derivative of sine? And the answer is negative cosine. And what gives us a derivative of cosine? And the answer is sine. So plus 3 sine t. All right, and then of course we always have to add in our plus c. So now just like before, we are going to substitute in this initial condition. So they're telling us when we plug in 0, we are getting an answer of 4. So that means 4 equals negative cosine of 0 plus 3 sine of 0. Okay, so remember your cosine of 0 is 1, and there's a negative in front, so that's going to be a -1. And then the sine of 0 is 0, so that's going to be 3 times 0 plus c. So we're going to end up with adding 1 to the left side of our equation, and that gives us a c value of 5. So in total, my position function is negative cosine t plus 3 sine t. Plus 5. Okay. Okay, I want you to try the next one. Okay, so if you have done the next one correctly, you should get s t cubed minus t plus 2. Okay, so let me know if you did not get that. All right, let's do another one together. This one kind of is combining a couple of different steps. So we have runner A, who begins at the position of 0, 0, runs at a velocity of 2t. Runner B has a head start at 0.08 and has a velocity of t. Velocity t equals 2. Find the position of the runners, find the time that they pass each other, and then determine who is ahead at the time 6 units. Okay, so there's 3 pieces to this problem. So the first thing that we're going to do is we're going to write down our velocity function for each runner. Okay, so we are going to integrate and find the position function. Okay, so in this case, it's going to be 2 times 1/2 t squared plus c, which is ending up being t squared plus c. Okay, so then we have when the runner starts at time 0, we end up with 0 for an answer. So we're getting 0 squared plus c. So c in this case has to be 0. Okay, so that means in total, my position function for runner A is t squared. Okay, so now let's do runner B. So for runner B, our velocity function was equal to 2, which tells me that my position function is going to be 2t. Okay, and of course, we always need to include our constant, c. So then we're going to solve for that now. So we get 8 when our time is 0. So 2 times 0 is going to be 0, which is telling me that in this case, my c has to be 8. Okay, so then we're going to plug that back in. So we're going to get 2t plus 8. Okay, so that answers the first of the 3 questions. Find the position function. And so then question number 2, it wants to know when the runners first pass each other. So in order to do that, that means their position would be equal, right? So what we're going to do is we're going to set our 2 position functions equal to each other. So we're going to say t squared equals 2t plus 8. So I'm going to get everything to the same side. So I'm going to get t squared minus 2t minus 8. I don't know why. Okay, minus 8 equals 0. And if I factor that, I'm going to end up with t minus 4 and t plus 2. Okay, so if I set each of those equal to 0, that's going to give me a t time of 4 seconds and then a t time of -2 seconds. And obviously, we're not going back in time, so that is not going to work. Okay. All right, and then the last question is, where are the runners at 6 seconds? So what we're going to do now is we're going to plug in 6 to our position functions for each runner. So we're going to get 6 squared, which is 36. And for runner 2 or B, that's a 6. So that guy is at 20. Okay. All right. So let's do one final example. There's a couple different parts for this example, just like this last one we did. Okay. So we're going to ignore air resistance, but the motion of an object moving vertically near Earth's surface is determined by acceleration due to gravity, which is approximately 9.8 meters per second squared. Suppose a stone is thrown vertically upward at a time t equals 0 with a velocity of 40 meters per second from the edge of the cliff, 100 meters above the water. All right, so it wants us to find the velocity function. So they've given us the acceleration, it's 9.8 meters per second squared. But since it's gravity, that means it's pulling down, so it's going to be negative 9.8 meters per second squared, okay? So acceleration with respect to time is going to be negative 9.8. I'm going to ignore my units for right now, okay? So if I'm finding the velocity, that means I'm going to integrate that. Okay, so I'm going to get negative 9.8t plus c. Now, they told me that the velocity with which the person threw the stone was 40 meters per second. So what that means, at time 0, my answer for this is going to be 40 meters per second. So I'm going to say 40 equals negative 9.8 times 0 plus c. Okay, so then we know, since I'm just multiplying the negative 9.8 by 0, that my c has to be 40 in this case. So that means I can rewrite my velocity function plugging in 40 for c. Okay, so we are done with that first part. The next thing, it wants us to find the position function. Okay, so our velocity function, I'm just going to rewrite it on this page, was negative 9.8 t plus 40. Okay, so now we are going to integrate that. So, all right, so now t has an exponent of 1 for this part, so I'm going to add 1 to it, which is going to give me 2. So I know I need to put a 1/2 in the front to take into account the fact that I started with a 2. So plus, all right, there's no exponent with my 40, which means I'm going to add a t front. All right, and then finally plus c. Okay, so let's clean this up. So half of 9.8 is going to be 4.9 t squared plus 40t plus c. Okay, so our person is standing at a cliff 100 meters above the river, which tells me that my position is 100 and I'm starting at time equals 0. So essentially, that's going to go away, that's going to go away, and I'm going to be left with 100 equals c. So now we can rewrite our equation, substituting in that value for c. Okay, wonderful. 2 more pieces and then we're done. Okay, so now we want to find the maximum height. So you know when we first did problems like these, we would have our cliff, right? And then the person would be throwing the rock and essentially it would go something like that, right? So we're looking for the maximum height, so we're looking for here. Now, I know that the tangent line is going to have a slope of 0 at that point. And if this line that the stone travels is my position function, and the tangent line is the equal to the first derivative, when the first derivative is equal to 0, I can find out the maximum height. Okay, so we're going to take our velocity function and we're going to equal it to 0. So 0 equals negative 9.8 t plus 40. So we're going to get negative 40 equals negative 9.8 t. And we'll divide by negative 9.8, which gives me a time of 4.08. So what is this telling me? This tells me at a time of 4.80 seconds, my stone is going to reach the maximum height. So now that I know the time where it's going to reach the maximum height, I can plug that into my position function to find the maximum height. Okay, so we are going to plug into our position function 4.8. And if we plug that in, we are going to get 181.63 feet, approximately. Okay, last thing. What speed does your object strike the river? Okay, so what you need to remember for speed is this is going to be the absolute value of your velocity. Okay, so the other thing to pay attention to is if we're striking the river, that means my position function is going to be equal to 0. Okay. So if you are looking at your position function, it's negative 4.9 t squared plus 40t plus 100. Now, you could try to factor that, but that's kind of really messy. So what do we do when we need to find the value of a quadratic that's not easily factored? Yay, we use the quadratic formula. Okay, so negative b plus or minus square root of b squared minus 4a c all over 2a. Okay, all right, so if I do that, I'm going to get two values for t. I'm going to get 10.2 and I'm going to get negative 2.01. Now, which one of those do I not care about? The negative one, because that would be going backwards in time and that would be too much. Okay, so now we're going to plug that time into our velocity function because we're trying to find the speed. So we're going to say, actually, I want to write it like this. Okay, so if I do that, I'm getting a velocity of negative 59.96. So I'm going to take the absolute value for my speed. So that's telling me that my speed is going to be 59.96, and that is meters per second. Okay.